Welcome back. We just finished day 23, part 2, and continuing on the stream, we're now going to do day 24 of the Advent of Code in Ruby. Let's switch this and not make the mistake I made last night and do like half my stream with my face full screened. Lobby layout. Your raft makes it to the tropical island. It turns out that the small crab was an excellent navigator. You make your way to the resort. As you enter the lobby, you discover a small problem. The floor is being renovated. You can't even reach the check-in desk until they've finished installing the new tile floor. Tiles are all hexagonal. They need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side and black on the other. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. The member of the renovation crew gives you a list of tiles that need to be flipped over. Each line in the list identifies a single tile that needs to be flipped over by giving a series of steps starting from a reference tile in the very center of the room. Every line starts from the same reference tile. Because the tiles are hexagonal, every tile has 6 neighbors: east, southeast, southwest, west, northwest, and northeast. These directions are given in your list, respectively as east, southeast, southwest, west, northwest, and northeast. A tile is identified by a series of directions with no delimiters. For example, ESENEE identifies the tiles you need to land on if you start at the reference tile and then move one tile east, one tile southeast, one tile northeast, and one tile east. Each time a tile is identified, it flips from white to black or from black to white. Tiles might be flipped more than once. For example, a line like ESEW flips a tile immediately adjacent to the reference tile, and a line like NWWSWEE flips the reference tile itself. Here is a larger example. In the above example, 10 tiles are flipped once to black, and 5 more are flipped twice, to black, then back to white. After all of these instructions have been followed, a total of 10 tiles are black. Go through the renovation crew's list and determine which tiles they need to flip. After all the instructions have been followed, how many tiles are left with the black side up? Okay, that's an interesting one. Just gonna shut the door because Amy's sewing. It's a really, she's sewing like a green and red fleece sweater for Roxy that has a Christmas tree with red ornaments on it on the back. It's really quite excellent. So where were we? We are now doing day 24, part 1. And we'll just open a random file and generate our skeleton. 4, take a little peek at the input, and I think maybe we'll just take this over to Rubular. See if we can Rubular this guy up, you know? And while we're at it, crack this LaCroix. So, what is it? There's northwest, there's northeast, there's, what was it? Valid directions, what did they want it? East, southeast, southwest, west, northwest, northeast. So northwest, northeast, southwest, southeast, west, and east. Okay. Sure. I think that works. So let's write a parser. Oh, I Let's go to start. Let's test drive a parser, you know? X maple. Okay. Now we're here. Now what are we doing? We could use we should just use the example that they give in here. I don't want to parse all of these though. Let's just parse like the first. Let's just parse one of them. let's just easiest possible thing here for this. So parser dot parse input. What do we call these? I don't know. Let's just do this. It's not a great API, but it's the API we got. And then instead of, let's use our good friend, the squiggly here doc right there. Just pop the result in line, and then we can do a little assert equal, and this is going to want to be like an array of array with an array in it, because it'll be like an array of each line, and then we want the individual instructions. So is the order in which you specify matches respected when the regex is evaluated, i.e. should be last because it appears in SE. I believe that I don't actually know the answer to that. I know that regular expressions tend to be greedy. They like try to match as much as they can, not the least they can, but I don't know how that works with a capture group like that. I'm not a regular expression expert. I don't know. Jay Hawthorne might have a better idea of the answer to that. I'm not sure. Or maybe someone else in here loves regular expressions more than I do. Oh, this is such a long one though. Yeah, I also think it should work. Just trying to come up with a way to format this that isn't terrible. I'm gonna do that. I don't know. This is not good. So then we should use user words in here to make this a little easier. So it's like northeast, east, east, northeast, southeast, northwest, northwest, west, southwest, northeast, northeast. Uh-oh. Oh, no, west, northwest, west, southeast, west, northeast, northwest, southeast, southwest, east, southwest. I think that's it. Let's run our tests. Okay, so argument error. Cool. Fix the argument error, get ourselves a parse method. Now we need to actually implement it. Now that's the input. Give me my regular expression. Now all right, where are we at here? Captures for nil class. Okay, that's intriguing. Oh, we want to. It's input dot split on new lines, right? Because we want to map each individual line. Split for nil class. Oh, because I'm not actually setting it. There we go. Try. Okay, so that's not what I expected. We got only the last one. So let's take a little peek in here and see what's happening. So line is what we expect. And match line is not doing what this says. Oh no, this is only showing one match. We need to, how do we do this? This isn't the right regular expression. This matches the match groups. Oh no, this is showing, I'm confused. Yeah, because it's just picking up the last one. Can I not have a, like, I guess I want a regex scan. I think you are right, Benjamin. Regex scan rubies. Oh, that's not what I want. Come on, just give me the whatever. API doc. API doc. Okay, so that's not how I do this. Oh, I do it backwards. Line.scan. And then we that looks right. I like it. I like it. Thank you, Benjamin. Nice. We got our parser working. Okay, so easy part. Now we actually just have to do something with that. Now, how do we want to do this? I have no experience with storing hexagonal tiles. As much as I got into programming because I wanted to make games, and that's what I did as a teen and later. I never did any hexagonal games. How do we want to store this? Is there an efficient way to do this, or do I? I don't want to like necessarily build up the whole grid of elements. How do we store hexagons? Map them to Unicode arrows. I don't know what you mean. I mean, you could do it as like a sparse. We could do it as like a grid where like not all of the possible XY coordinates are valid. That's one way to do it. Because like, so you could have 0, you know, the initial position be 0, 0, and to go left you go like -2 in the x-axis, and to go right you go +2 in the x-axis, and to go up left you go -1 in the x-axis, +1 on the y-axis. So that would work. Then we just store the ones we flip and in like a hash or something with the keys where the keys are the coordinates. Does that sound fun? Do we like that idea? I did a drawing. I can't actually show you this piece of paper, but yeah, there you go. So I'm just gonna model it as a grid. So I think that's a fine way to do it. We'll see how far it gets us. So we have our input, and our input will parse here so that it is in the state we want it in. And and let's write our test because we're given an example. So we can put that in as our test data. Sweet. And I think it said 10. 10 tiles are black at the end. Yes. So we are going to let's keep a tiles hash here. And then input.each. So for each set of instructions, we will do this operation. And I guess I'm going to build a just going to build a hash of what all of the directions mean. So if we want to go east, that means that we're going -2 in the x-axis and 0 in the y-axis. We have like 6 directions, so we can go west. That is the opposite of doing that. We can go northeast, which is only -1 and 1. We can go southeast, which is -1, -1, and -1. We can go northwest and northeast. So these are going to be that and 1 and -1 respectively. So now we can look up the instructions pretty easily. So we'll say our initial position is going to be 0, 0, right? And then instructions, loop over our instructions, and for each instruction we will do position 0. We do += directions I first. Do you just know did you just know those offsets? I use a 3D version and have to look it up each time. I have northeast twice. I do. Thank you. That was supposed to be southeast. I just drew them out as I was southwest. I just drew them out on a piece of paper. That was just like, what can I do to map this into a space I understand? So So yeah, I just drew it out. And then we want to flip that one. So if tiles position, then we want to do one thing. Now, just double check my Ruby hash API here. There's delete takes a key, right? Yeah. So if it's already been set, then we delete it because we're only keeping track of the black ones. Otherwise, we set it. I'm just gonna use true because it doesn't really matter what the value is as long as it's truthy. And then we're going to return I can kind of draw it out actually. Here, let me so it's not a beautiful drawing, but I think it'll convey the idea. How I've mapped this out. So yeah, so if like the dots I've colored in are the actual grid, so you can see that there is in the center we have 0, 0, and to go to the next tile along the same thing here, we go 2 stops over. But then to go up and to the right, we would go 1 up and 1 to the right. I don't know what direction I'm going. Everything's backwards, but yeah, once you draw it out, it's a little easier. Hexagonal grids. Ah, that is a useful resource. Thank you. I think one of the things I want to do on this channel after this Advent of Coded stuff is done is do some roguelike dev on it, because I've toyed around with all that, but with a lot of it before, but never got super far, so I think it'd be fun to do here. Somewhere I wrote post, cool. And we get the wrong answer, so wouldn't northwest be 1, 1 -1? No, the x. So to go. The x is first. So we're going backwards. Or I don't know how you want to describe that, but to go west, you go negative along the x-axis, assuming your x-axis. Yeah, cool. I didn't get the right answer though, which is interesting. And that's because I just didn't even slightly do this right. I was just only incrementing the code says 1, 1. Interesting. Yes, I mixed my directions up. Thank you. Okay. So when I said I just sort of knew it off the top of my head, I meant I totally had it wrong. But thank you for helping me get there. Now we're still getting the wrong answer. So now I gotta think about this. East is because my east and west are also flipped. Okay. There we go. No, you're not distracting me. You just helped me find the solution. I think that's probably the answer now. Yeah, there we go. Part 1 complete. Let's just commit that, and let's take a look at what part 2 is. Day 24, part 1. All right. Part 2. The tile floor in the lobby is meant to be a living art exhibit. Every day, the tiles are all flipped according to the following rules. Any black tile with zero or more than 2 black tiles immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. Here, tiles immediately adjacent mean the 6 tiles directly touching the tile in question. The rules are applied simultaneously to every tile. Put another way, it is first determined which tiles need to be flipped, then they are all flipped at the same time. In the above example, the number of black tiles that are facing up after the given number of days has passed is as follows. After executing this process a total of 100 times, there would be 2208 black tiles facing up. How many tiles will be black after 100 days? Okay. So let's just store that in instance variable. Cool, same answer. And let's just start running part 2 now. When I do my binding, so we can use our same example to start coding part 2, and we're just going to initially call super, and then we're going to have to do like 100 times something, and then print tiles.count. So, and I believe it was 2208 that it said. Yeah, 2208. Cool. So we've got a failing task. Have to implement this sort of game of life-y logic for this. Okay, so probably do something similar to what I did for my like the previous game of lifestyle stuff. So we only need to check the tiles that are immediately adjacent our black tiles and our black tiles. So we can build a list of all the tiles that need to be checked, because if, because that's how just the way we've implemented this. Yeah. So we'll build like a new tiles, and then we'll, at the end of this, set new tiles to be equal, or sorry, tiles to be equal to new tiles. And we just have to worry about what's in the middle. So we need to iterate over all the possible tiles. The possible tiles are going to be tiles.keys.flatmap, and this is a fun one. Oh, I have an idea. So we can have no movement in here, and then I can just use this to map things together. So XY, and then we do dirs.map, do dx, dy, and this is just dx plus x, dy plus y. And that should give me a list of all of the adjacent tiles and themselves out of the gate there, right? If we didn't make some mistake, which we definitely did. Okay, so possible tiles. This is going to contain duplicates potentially. Excellent. So now we have a list of all the coordinates we need to check. That'll come in handy. Make sure we add that unique so we don't redo any work. And then we're going to do possible tiles each do. Let's just take a quick look back at those rules to make sure we understand. Black tile. You could come about it the other way and check the neighbors of all the black tiles instead. That's essentially what I'm doing. That's all I'm building a list of, is the neighbors of all the black tiles and the black tiles themselves. That's what that list builds. Because I only store values in my tiles hash if they're black. I delete them if they're not black. You can do the counts in that same pass. It could. Where's the dupes? This allows me to remove the. I don't know what you mean by leverage of the dupes, because like I'm. If an item appears twice, it has 2 black neighbors. Yeah. Interesting. Yeah, I guess I could do that. That'd be kind of an interesting optimization. I feel like it's easier to wrap my head around it this way though, but I do like that. So where was I? It would be yeah, yours would definitely be faster. What are the rules again? So for the black, so I guess we want to say if tiles so if it's a black, otherwise it's white. And okay, so the problem with the thing I did now though is that I can't use this same hash, so I don't really like that. This is a terrible name for this. Do not try this at home. What was it? A map to 0, 0. Cool. All right. So we'll just get the number of tiles adjacent to this guy that are black. So this is x plus dx, y plus dy. We'll just be nice and consistent and swap those. Thanks. Have a good rest of your Christmas Eve. So this is, we want to set new tiles x, y, if this value is 2. This is 2. Right? Otherwise, I'm going to do something else, which is this should be equals true. It works. Does it produce the right answer? Amazing. Well, that is it for day 24. Success. That went quite smoothly. Kind of enjoyed the hexagon thing. I'd never done that kind of little hexagon grid conversion math thing, but it worked really well for me. I will be back again this evening for the final day 25 of the Advent of Code. This is the furthest I've ever got. I'm really happy to hopefully finish it tonight. So thanks everyone for coming, and I will see you tonight.